Hello, I am Yongqin from MPI Informatics. In this video, I will present our generalized many-way few-shot video classification. This is a joint work with Bruno, Matthijs, Bernt, Zeynep, and Lorenzo. Few-shot learning has attracted increasing attention because of the expense of obtaining labeled data. In this work, we are interested in few-shot video classification, where the goal is to predict the action labels of videos with a small amount of labeled training examples. The training set consists of a set of base classes with many labeled videos per class, and a disjoint set of novel classes with only a few labeled videos per class. The goal is to learn classifiers that generalize well to unseen videos of novel classes. The general pipeline for few-shot learning is as following. In the representation learning stage, we learn the video representation on base classes. Then we use the learned backbone to extract features for novel classes and learn novel class classifiers with only a few examples. Previous few-shot video classification approaches mainly focus on improving the few-shot learning stage. The compound memory network and the temporal alignment modulars are proposed in IPCV 18 and CVPR 20 respectively. However, we argue that they are limited because they rely on 2D ConvNet to extract frame-level features that ignore temporal information. Besides, their evaluation setting only considers 5-way classification that is not sufficiently challenging. Here is an overview of the talk. First, I will introduce a simple 3D ConvNet baseline that outperforms the state-of-the-art by a large margin, followed by an efficient retrieval approach to leverage tag-labeled videos. Finally, I will introduce our more challenging evaluation setups. Let's first look at our simple two-stage baseline called 3D FSV, 3D ConvNet for few-shot video classification. The first stage is representation learning, where we fine-tune a pre-trained R2 plus 1D on base classes of the target dataset. More specifically, the R2 plus 1D takes as input a short video clip with 16 consecutive frames, which are randomly sampled from a training video with arbitrary length. The R2 plus 1D consists of 34 convolutional layers, where each layer performs a 2D convolution spatially, followed by a 1D convolution temporally. The last layer is a fully connected layer followed by softmax to predict the posterior class probabilities. The whole network is trained end-to-end with a cross-entropy loss. It is worth noting that we perform temporal data augmentation by repeatedly sampling 10 different video clips from one training video. In the second stage, we would like to learn classifiers for novel classes with only few short videos per class. In this stage, we simply fix the R2 plus 1D backbone and only learn the FC layers with few short videos. Again, we apply temporal data augmentation by sampling 10 different short video clips from one video. In the testing stage, we evaluate the learned classifiers on the holdout test videos that come from novel classes. In this stage, we need to make predictions on a video with arbitrary length, but the R2 plus 1D only makes clip level prediction. In order to make video level prediction, we randomly draw 10 clips from the same video and take the averaged prediction. Previous works are mainly evaluated in the 1-shot 5-way and 5-shot 5-way settings, where only novel classes will be predicted. We follow the same data splits on kinetics and some SynV2 datasets proposed by previous works. We first compare with the state-of-the-art in 5-way few-shot classification following the prior setup. The results show that our simple baseline 3D FSV outperforms the state-of-the-art by a wide margin on both kinetics and something V2 datasets, which implies that video representation matters a lot for future video classification. A simple baseline are already outperforming the state-of-the-art with good feature. In order to circumvent the need of labeled examples for novel classes, we propose an efficient retrieval approach to leverage tag-labeled videos from the YFCC 100 million dataset. More specifically, for each novel class, we retrieve the most relevant videos from another large-scale dataset to expand the training data of this novel class. So for each of the novel classes, we first retrieve a list of candidate videos by computing the nearest video tags of its class name in the text embedding space. However, those retrieved candidate videos can be quite long and include a large number of irrelevant frames. Therefore, we propose to select the best top K 16-frame clips from those candidate videos with visual similarities by comparing the video clip embeddings extracted from the fine-tuned R2+1D. We combine the retrieved video clips with the few-shot training videos to learn classifiers for novel classes. Here we show the 5-way classification results on kinetics datasets. Our Retrieval-Enhanced 3D FSV leads to further improvement at 1 shot, and results on kinetics are almost saturated at 5 shot. Therefore, we propose more challenging evaluation setup, including many-way few-shot video classifications, where we extend the number of novel classes up to all 24. Prior few-shot video classification only predicts novel classes at the test time, which is unrealistic. Therefore, we propose generalized few-shot video classification setting where the model has to distinguish both base and novel classes. Here we show the results in the many-way few-shot video classification. The x-axis is the number of evaluated novel classes, and the y-axis is the top 1 accuracy on novel classes. The results show that the performance decreases with the increasing number of novel classes, and 24-way classification is still challenging. Besides, the results also show that our Retrieval-Enhanced R3D FSV consistently improve the baseline. Here are the generalized few-shot video classification results, where the model must distinguish both base and novel classes. Our results show that there is a big performance gap between novel and base classes in generalized few-shot video classification setting. However, this issue can be alleviated to some extent by our R3D FSV. We also advocate the community to focus on this direction for the future research. To summarize, in this work, we propose a simple 3D convenet approach that outperforms the state-of-the-art by a wide margin. Second, we propose a retrieval-enhanced approach that retrieves tag-labeled videos to expand the data for novel classes, which leads to further improvement. Finally, since our results saturate current evaluation settings, we propose more challenging evaluation settings for future research. That's all of this talk. Thank you.